Hello guys, how you doing? I'm Rahul and you are watching the Concept Builder, and today we are continuing our absorption topic, mass transfer phenomena. And the special topic today we're gonna cover is, first one is the desorption, which is also called as stripping. Okay, what is desorption? As the name suggests, it's reverse of absorption. So absorption we have already studied, and what was happening in it, that the solute was getting transferred from the gas phase to the liquid phase. But as the name suggests, desorption is just reverse of absorption, so it will be solute will transfer from liquid gas to the gas phase. So that's gonna be very easy. Okay, so it just is the reverse of the absorption, as we have seen. In this case also, if you see that in this case x2 will be greater than x1, because the liquid has already very high amount of solute, and the gas entering from the bottom will have almost zero amount of solute or very less amount of solute. And as the gas will pass through the column, the solute content in it will increase, and the solute content in the liquid will decrease. First we have to find the solute balance, and from this material balance we can find the operating line, and so let's find it. Okay, now you can see that operating line equation is same as our absorption operating line equation, so that's very easy. Now the question is, if the operating line is same and equilibrium line will also be same, then how the y-x graph will look like? Will it be same like absorption, or where the operating line will lie? Will it lie above the equilibrium line, or will it lie below the equilibrium line? So that's question you have to answer. In this stripping kind of situation, the operating line will lie below the equilibrium line. So that was our first important concept. Now what you have to do is you have to mark which point is the top point and which point of the operating line is the bottom point. Remember that we have defined our top as 2 and the bottom as 1. As you can see, then in this operation our gas is coming from the bottom from point 1, and it has lowest composition. That's why the lower point should be y1 and x1, and the upper point will be y2 and x2. That's easy. And now there will be mass transfer from operating line and from between the equilibrium line, and you can draw the stages like these, and it's same like absorption but just reverse of it. In the stripping we will have stripping factor, and the stripping factor S will be equal to 1 divided by absorption factor. So just inverse of the absorption factor is stripping factor. So guys, as you have seen, the stripping was very easy, so just opposite of the absorption, and nothing else very complex is happening over here. It's just very simple. So make sure you subscribe. And the next topic we're gonna move on is the concurrent absorption. Okay, so you have seen that in our previous video we were using the absorption process in which the gas and liquid were entering from the opposite direction. So the liquid was coming from the top and gas was coming from the bottom, and this is known as yes. But now in this lecture we're gonna look at what will happen if both gas and liquid will enter from the same side, and this operation is known as cocurrent operation. Okay, both are entering from the same direction. Suppose both are entering from the bottom, so let's define our variables x1, y1, ls and gs similarly. And what you have to do is you have to just take a section as we have taken in our absorption and stripping section video, and what you have to do is you have to apply the material balance. The material balance is Apply the material balance. What you will write? Y1 minus y equal to ls times x1 minus x. This thing we have already done in our stripping derivation and also in our absorption derivation in the previous videos, but in this video what's happening that both streams are coming in from the same direction. So what's happening that the gas concentration is decreasing and the liquid concentration is increasing. So you will see that the y1 minus y will positive, but the x1 minus x will be negative because the liquid concentration is increasing because the liquid is absorbing. So while deriving, what you will see that just the slope will be minus times. So here if you derive here, yes, and you will get the operating line as y equal to minus ls upon gs into x plus the constant. Okay, so that's it. That's the only difference between the co-current and the counter current operation. In the co-current operation, there are gonna be the operating line have the negative slope, and so let's look at in our traditional y-x graph. So y and x are the mole ratio, and let's draw our equilibrium curve like this. We are assuming a straight line, but and because it is absorption, so the operating line should lie above the equilibrium line. And if you will draw it, you will see that it has negative sign, so it will be like this. Okay, now here is very interesting thing coming up at the initial point, which are the x1 y1, and if you see that there is a huge gap between the operating point and the equilibrium line point. But as we go on, this is decreasing, and the operating line will meet our equilibrium line. And we know that if does happen, that's not good, because as we will move on, as we will go on, we will see that the mass transfer rate will decrease, and so we cannot continue this operation for long time, because after that the rate will decrease, and to complete this we will need a very high column.